What answer did you give, David?
So my answer is that the best explanation is a combination of beta-ptosis and zeta-ad. By combining these two illnesses, we can cover all of the data we saw over here. We saw both illnesses elevate B, which led to our high B, and both reduce C, which led to our low C. Our patient had a normal level of E, but the effects of beta-ptosis and zeta-ad counteract their influence on E. Then zeta-ad accounts for our reduced F, and beta-ptosis accounts for our reduced H. My explanation, though, heavily weights the principle of coverage. I sacrifice parsimony by having two different explanations. For the sake of coverage, I now cover all the symptoms. I could have also chose thetadesis. Thetadesis would have explained B, C, and H. It wouldn't explain F, but it would be a simpler explanation than the combination of beta-ptosis and zeta-ad. In that case, I would be sacrificing coverage for parsimony. I could also augment thetadesis with capacide and mutention. The three of them together would cover all our symptoms, but that would also be less parsimonious than beta-ptosis and zeta-ad alone. I may have chosen to do that, though, if those three diseases were much more common than beta-ptosis and zeta-ad, in which case I would have more confidence in them than just these two.
That's an excellent answer, David, but how did you come up with this answer?
So what I did is I started with the data, and I looked at which of these hypotheses currently match the data the best. That is to say, which hypotheses explained the most points and had the fewest conflicts. So for example, beta-ptosis explained the high B, the low C, and the low H, but it didn't explain the low F, and it also suggested there was elevated E. Initially, thetadesis was the best match. It explained 3 symptoms and just didn't explain a 4th. Then based on that, I went looking for another illness that would complete the explanation. For thetadesis, that ended up leading me to capacide and mutention, but at that point I was using 3 different hypotheses, so I decided to revisit one of the closer matches from my original round. I revisited beta-ptosis, which had 2 mismatches. It predicted elevated E and didn't explain the reduced F, and I went looking for another hypothesis that would complete that explanation. Zeta-ad happened to have exactly those 2 effects.
Note that one can use alternative methods for the same problem. For example, one could use case-based reasoning. In fact, we came across a problem very similar to this one previously. Suppose that the solution of that particular problem was available as a case. In that particular case, B was high, C was low, and H was low, and the solution was thetadesis. In the current problem, the additional symptom is that F is low. So case retrieval would first lead to the conclusion of thetadesis. Now we need to tweak this particular solution to also account for the additional symptom of F being low. We could do that by adding capacide and retention to thetadesis. Case-based reasoning thus would tend to focus the alternative set of hypotheses. One more point to note here then. Note that different methods can lead to different solutions. Given different methods, how might an AI agent decide which method to select? We'll return to this particular problem when we discuss meta-reasoning.